Hey guys, welcome to lesson 1.4. Today we're going to talk about inverse functions. So for a quick review, how do we know if something is a function? So let's really quick consider these three relations before. How do you tell if these graphs are function? We have figure A, figure B, and figure C. That's right, the vertical line test. If I was to do the vertical line test on graph A, you will see that it hits two spots, making it not a function. It failed the vertical line test. However, on B and C, it passes the vertical line test. Once a graph passed the vertical line test, see here it hits one spot, it means it is a function. Now we're going to get into something called the horizontal line test. And we use a horizontal line test to tell whether functions are one-to-one. So place a horizontal line anywhere on the graph and it has to intersect at most one point. Once it passes the horizontal test, it's a one-to-one function. So, figure A. If I was to do place a horizontal line, remember horizontal line are parallel to the x-axis. It will intersect, as you can see, one spot. This graph represents a function for which every value of f of x, which is my output, is associated with only one value of x. Such functions are called one-to-one. So when the output is just associated to one value of x. And again, you can tell if a graph is a one-to-one by just doing a horizontal line test. Let's look at figure B. On the opposite ends of thing, if I was to do a horizontal line test, it hits at two spots here, making it fail the horizontal line test, and it's not a one-to-one function. So moving along, determine whether this graph is a one-to-one. So remember, one-to-one means I do a horizontal line test. So my solution, if I was to do a horizontal line test, we will see it hits 1, 2, 3, and automatically failure. Failed the horizontal line test, meaning it's not a one-to-one function. Now it's your turn. Your turn, problem 1, meaning this is the first one you try on your own. Tell me, what do you think? Is this graph a one-to-one function? How do you know? How do you know? How do you know? You should tell me that yes, this is a one-to-one function. If I was to sketch a horizontal line anywhere on this graph, it hits only 1 point, making it pass the horizontal line test. So that means it's a one-to-one. Now, what if I was just given a function? Let's see, f of x is equal x to the third plus 3. No graph or anything. How can you tell? Well, we all have the TI and Spire, which help us too much for the regions. We're going to go to y equal and enter x to the third plus 3. When you enter that and you hit graph, you will see a graph that looks identical to what I have here. If you're not sure how to enter this, come see me, okay? Once I enter this and I do my horizontal line test, I will see that it only intersects at one spot every time I do the horizontal line test. So that means it passes the test, and when a graph passes the horizontal line test, it implies and it tells me that it is a one-to-one function. Now it's your turn again. Try to do this one on your own. Again, go to y equal to get the absolute value. Remember, easiest way, just type ABS parentheses x plus 1 close parentheses minus 2 and go to your graph. Tell me what you get. You should get something now looks like this picture right here. If I did the horizontal line test, I see that it touches at 2 points, meaning it fails the test. It's not a one-to-one. Alrighty. So now that we talked about one-to-one function, we can talk about inverse functions. So two functions, let's say f and g, are inverses of each other if the following statements hold. F of g of x is equal to x, and g of f of x has to equal to x. So I just put in this line here, the values in the domain of the function f will be the same as the range of the function. Only functions that are one-to-one has inverse functions. So the first thing you have to do is check, are these functions one-to-one function? Without that, it would not have an inverse. So that's the first thing you need to do. So here, verify that the function are inverses of each other. So I'm given f of x equals 6x plus 5, and g of x is equal to x minus 5 over 6. I know that f of g of x has to equal to x, and I know that g of f of x, has to equal to x. But I have to show this mathematically. So the first one we're going to do is f of g of x. It doesn't matter which one you do, because remember, we know what the outcome is. We just need to set this up. So this is the same thing as f of g of x. So g of x, I look at my g function, that's x minus 5 over 6. So it becomes f of x minus 5 over 6. So now I'm going to use my f function, which is right here, 6x plus 5. Wherever I see x, I'm going to replace it with what's in my parentheses. I will get something that looks like this. 6 parentheses x minus 5 over 6 plus 5. Remember, all I did was replace this x with what's in my parentheses. The 6 are cancelled off. I left with x minus 5 plus 5. These minus 5 plus, since my minus 5 and my plus 5 cancels off, I'm left with x. Now I know that part is correct. I need to do the other part right here, g of f of x. So in this case, f of x again is 6x plus 5. I know I'm going to find g of 6x plus 5. Remember, inner parentheses, then my outer. Using my g functions, wherever I see x, I'll replace it with 6x plus 5. I will get something that looks like that. 6x plus 5 in parentheses minus 5 over 6. I'm using my g of x function. The 5's are cancelled off. I'm left with 6x over 6. And then the 6 divided by 6 is 1, which is the same as x. So now that I know these two are equal to each other, then f of x and g of x are inverses of each other. Note that the domain of f, all real numbers, is also the range of g. Similarly, the range of f is also the domain of g. Remember, we talked about domain and range. This is just saying inverse function means the domain of f is the range of g, and vice versa. Now I want you to try this. I want you to verify that f of x is equal to 40 minus 7x, and g of x, which is 40 minus x divided by 7, are inverses of each other. Take a few minutes, pause the video, work this out like I just did to show me that f of g of x is equal to x and g of f of x is equal to x. This is what you need to show me, that f of g of x is equal to x and g of f of x is equal to x. Continue taking your notes. If you have a problem showing me this mathematically, pause the video, come and see me so we can go over this individually, okay? You need to know how to prove two functions are inverses of each other. So, the symbol that indicates a function is an inverse of an original function. F is f to the negative 1 with the exponent. When you see that, f to the negative 1 is read out as f inverse or the inverse of f. It can be any letter. If it has g to the negative 1, it's just say g inverse or the inverse of g. To do this, there are 4 steps that we're going to do. First thing we're going to do is replace the f of x or whatever the function's name is with y. We're switching the x and y. We're going to solve for y. And then we're going to replace y with f inverse of x. And we'll see how this goes in our video. So let's investigate this one-to-one function. I have f of x is equal to 2x minus 1. So grab your calculators, go to y equal, enter 2x plus 1. We will see, of course, that this has a y-intercept of -1 and a slope of +2. So this is what my table will look like. Remember, you can plug this in for x and get the y value. Either way works. And remember, I told you about 3 or 4 points is good enough to sketch a line. So this is my graph. I know it's a 1-to-1 because if I do the horizontal line test, it will hit at only 1 point. So since this is a 1-to-1, it will have an inverse. Remember, that's the first thing we need to check. Is it a 1-to-1 function? Yes, that means it'll have an inverse. So graphically, when you're doing an inverse, remember when you did reflection with Mr. Siegel? Across the line y equals x. Reflection across the line y equals x. Hope you remember the rule. Is basically switching my x and y. So that's my line y equals x that I just drew over here. One way to plot the inverse is just to switch the x and y of the original function. That's the rule, guys. Remember, Siegel told you that's the rule when you reflect over the line y equals f. You can even draw a graph, a table that looks like this, and switch it. So now my x becomes -3, my y becomes -1. If I was to plot that, you will have the graph, this line in green, and that's your inverse function. So for graph, you need to get the table and just switch the values, the x and y, and then just plot the line. That's it. However, let's see how do we do this algebraically. So one last thing that we need to do is come up with a procedure for finding the equation of an inverse function if we're initially given it's a 1-to-1. So let's say f of x equals 6x minus 11. I know it's a 1-to-1. If I'm not sure, I will graph it and do the horizontal line test. So step 1 says, and remember, write the steps so you're familiar with what's going on. So I was given f of x equals 6x minus 11. Step 1 says, replace f of x with y. So I did it right here. Step 2 says, switch my x and y. I'll get x is equal to 6y minus 11. Step 3, solve for y. So I'll add 11 on both sides. And I'm going to get x plus 11 is equal to 6y. Divide everything by 6, and I will get x over 6 plus 11 over 6 equals y. Then I just switch it so I have y on my left-hand side. Now my final step is to just replace y with f inverse of x. And that's my final answer. That's it. 4 simple steps that you need to know. Write it down. After a certain time, you'll get to know it like this. So your turn is to try problem 4. If g of x is equal to 4x plus 31, find g inverse of x. To give you a few minutes, pause the video and try. So, did you get f inverse? Whoa, I shouldn't use f, it should be g inverse. Perfect. So, as you can see, we have to be consistent. They call the function g of x, and I made a mistake and said it's f inverse. So, no. We have to be consistent with whatever they call the function. In our example, it was f of x, so my inverse would have been f inverse. In this case, as you can see, I crossed it out. Be careful, this is a very simple mistake, and even I made it. So, g of x, because they call the function g of x, my answer is to find a g inverse. So you should get g inverse is equal to x divided by 4 minus 31 over 4, or g inverse is x minus 31 divided by 4. Either one works. What you're going to do now is go on to portfolio 1.4 about inverse function. Remember, if you need clarification before you move on, just come and check in with me or Miss Ewing. Alrighty, guys.